Okay, students, so we're doing triangle congruence proofs phase 1. So today we're going to do a bunch of 2-column proofs. That's going to be the punchline really of the rest of the unit. However, just to get warmed up, let's start talking about things, all right? We're going to identify which triangle congruence postulate theorem would state that the two triangles are congruent. Realize that some problems might not have all the markings. Recall that our choices are SSS, SAS, ASA, AAS, and HL. All right, so remember the S's mean side, A's mean angles, H means hypotenuse, L means leg. This one right here, let's see, we got a side, a side, a side. So this is side, side, side. This one right here, we have a side, we have another side, and in between, this is an included angle. It's between the two congruent sides. All right, so just how the angle is between both sides, the A will be between both S's. Side, angle, side. This one right here, this brown angles didn't even have to be marked because we know that they're congruent by vertical angles, but that was nice and gave it to us. This one has two A's and an S, but the S, the side, is between the congruent angles. This is another included side, so it's angle, side, angle. It's between the angles, so the S has to be between the A's. Remember, the combination of these letters are very specific. This one right here, we have a right angle. This right angle is important. All right, now with respect to these right angles, this is the hypotenuse. All right, it's opposite the right angle. And then we know the shared side is congruent by reflexive, so we have a leg. All right, so H, L. And then this last one, we have an angle, we have an angle, we have a side. This is a non-included side. It's not between both angles. It only touches one of the congruent angles. So just how it only touches one of the congruent angles, the S will only touch one of the A's. That's it right there. A little warm up. All right, and over the next few days, we're going to look at 6 popular theorems and definitions that are commonly used to prove that triangles are congruent. We'll also be practicing applying these theorems themselves. So reflexive property, that's when triangles have an angle or side in common. So we're just going to draw some example stuff. All right, we'll literally just draw this example we saw. Boop. All right, and I'm going to call this M-A-T-H. Math. Get it? I made the triangle spell math. Isn't that funny? However, we know that AT, segment AT is congruent to segment AT. We know that these two sides are congruent by the reflexive property. It's a shared side. All right. So let's do our first 2-column proof. And this is where I think you guys really start to get good at 2-column proofs. Why? Well, let's just dive in and find out. We have our givens, so it's incredibly important we take these givens and mark them on our triangles. BC, BA, CD, AD. All right? It's important to draw on our triangles now because now I visualize what information I have. So let's go from there. Let's just write that down really fast. BC is congruent to BA. CD is congruent to AD. Given. All right, so I wrote down what was given to me. Now, looking at the picture, I can easily say, boom, BD is congruent to BD. That was a weird BD I drew, but nonetheless. All right, this has to be free points. We have to be really good at this. When we see a shared side, we have to know that it's congruent to itself. Oops, I don't know why I started writing given. By reflexive property. All right. So this is one of the reasons why I think we start to get good at it, because I have a side, I have a side, I have a side, I have all three pieces of information I needed. So really from here, I can say that these triangles are congruent. I can write my congruency statement. And it's by the side, side, side congruence theorem. All right, that's it. That's the punchline. Stay tuned for more proofs.